Welcome to this comprehensive guide on SQL and NoSQL databases. In today's digital world, data storage is critical for every business and application. But how do you choose the right database for your needs? That's exactly what we'll explore. We'll compare two fundamental database approaches: SQL, which stands for Structured Query Language, and NoSQL, which means non-relational databases. By the end of this series, you'll understand the key differences, advantages, and disadvantages of each, and you'll be able to make informed decisions about which database system suits your project best. Let's begin this journey into the world of data management. SQL stands for Structured Query Language. It's a standardized programming language specifically designed for managing structured data in relational databases. Think of SQL databases as organized filing cabinets with clearly labeled drawers. SQL databases follow several important principles. First, they comply with ACID standards, which means atomicity, consistency, isolation, and durability. This ensures your data is reliable and safe. Second, SQL databases deliver high performance with optimized query execution, even when dealing with large amounts of data. Third, they use a relational model where tables are connected through primary and foreign keys, ensuring data integrity. Finally, SQL includes built-in security features with authentication and authorization mechanisms to protect your data. SQL is the most mature and widely supported database technology available today. Let's break down how SQL databases are structured. SQL organizes data into three fundamental components. First, we have columns. Columns are vertical attributes that define fields in your database. Each column stores a specific data type, like numbers, text, or dates. Second, we have rows. Rows are horizontal records containing actual data entries. Each row represents one unique record or instance. For example, if you have a student's table, each row would represent one student. Third, and critically important, are keys. A primary key is a unique identifier that ensures no two rows are identical. Every table must have a primary key. Then there's the foreign key, which creates relationships between tables by referencing another table's primary key. This relational structure is what makes SQL databases powerful for complex operations and data integrity. For example, a student's table might have an ID as primary key, plus columns for name, age, and course. Each row would represent a different student with their information. NoSQL stands for non-relational database. It's a flexible database system designed specifically for unstructured and semi-structured data. Unlike SQL's rigid structure, NoSQL prioritizes scalability, performance, and flexibility. NoSQL databases are incredibly scalable. They can expand horizontally across multiple servers, allowing you to handle massive datasets efficiently. NoSQL also offers a flexible schema. Instead of defining a rigid table structure upfront, NoSQL allows your data format to change and evolve dynamically. This makes it perfect for rapidly changing application requirements. NoSQL delivers high performance, optimized specifically for fast read and write operations and real-time data processing. Finally, NoSQL is distributed by design. It's built from the ground up to work across multiple machines with eventual consistency and high availability. If one server fails, your data is still accessible from other servers. Now let's compare SQL and NoSQL directly. Structure is the first major difference. SQL uses table-based structures with rows and columns, while NoSQL uses document-based, key-value, or graph-based structures. Schema is another crucial distinction. SQL requires a predefined, rigid schema that you must plan before storing data. NoSQL uses dynamic and flexible schemas, allowing you to change your data structure anytime. When it comes to scaling, SQL scales vertically. This means upgrading your single server with more memory, processing power, or storage. NoSQL scales horizontally by adding more servers to your network. Consistency is handled differently too. SQL ensures ACID compliance, meaning your data is always consistent. NoSQL uses eventual consistency, known as base properties, which means your data might temporarily be inconsistent across servers but becomes consistent eventually. Finally, the query language differs. SQL uses standard SQL syntax understood everywhere. NoSQL databases use database-specific languages or formats like JavaScript Object Notation or XML. Understanding when to use each database is essential. SQL works best for financial transactions because it guarantees data accuracy and consistency. Banks and financial institutions rely on this. SQL is ideal for customer relationship management systems where complex queries join multiple tables. SQL excels at business analytics and reporting where you need detailed insights from structured data. Healthcare records use SQL because medical data must be precise and auditable. Enterprise resource planning systems also prefer SQL for managing complex business operations. NoSQL, on the other hand, is perfect for content management systems where content types vary widely. Mobile applications benefit from NoSQL's flexibility and speed. Social media platforms use NoSQL to handle billions of posts and interactions in real time. Real-time e-commerce catalogs need NoSQL's speed to update thousands of product listings simultaneously. Big data analytics relies on NoSQL's ability to process massive volumes of diverse data quickly. Let's examine the strengths and weaknesses of each approach. SQL advantages include guaranteed ACID compliance ensuring data integrity, support for complex queries using joins to connect multiple tables, strong consistency guarantees so you always know your data is accurate, and mature technology with decades of support and development. However, SQL has disadvantages. It only scales vertically, so there are hardware limits. Making schema changes can be difficult and time-consuming. SQL is less flexible for unstructured data like images or videos, and performance can degrade with extremely large datasets. NoSQL advantages include the ability to scale horizontally across unlimited servers, flexible dynamic schemas that evolve with your needs, exceptional availability and performance for real-time applications, and excellent handling of unstructured and semi-structured data. NoSQL disadvantages include eventual consistency, meaning temporary data inconsistency, limited support for complex queries and relationships, newer technology with less community support, and data duplication challenges that require careful management. Now let's discuss performance characteristics. SQL read speed is optimized for complex queries, making it efficient when you need to combine data from multiple tables. SQL write speed is moderate because the system validates data against the schema before storing. SQL throughput supports fewer concurrent operations since the single server can only handle so many requests simultaneously. SQL latency is consistent and predictable, which is valuable for applications where performance variability matters. NoSQL read speed for simple key-value lookups is extremely fast, returning data in milliseconds. NoSQL write speed is very fast because there's no schema validation overhead. NoSQL throughput is much higher, supporting thousands or millions of concurrent operations across multiple servers. NoSQL latency is lower at scale because horizontal scaling distributes the load. In summary, SQL excels with complex analytical queries and data integrity requirements. NoSQL dominates in high-volume transactions, real-time data processing, and scenarios requiring rapid scaling. The scalability difference between SQL and NoSQL is fundamental. SQL uses vertical scaling. This means improving a single server by adding more RAM, upgrading the CPU, or adding storage. It's like expanding a building upward by adding more floors. However, vertical scaling has limits. Eventually, you reach the maximum hardware available. The costs increase dramatically, and you create a single point of failure. NoSQL uses horizontal scaling, which means adding more servers to your network. It's like building more buildings instead of making one taller. With horizontal scaling, you can add servers indefinitely. Data distributes across servers, so no single failure brings down the system. Adding servers is cost-effective, and you gain better redundancy. The key insight is this. Horizontal scaling with NoSQL is ideal for modern cloud-based infrastructure where you can spin up new servers easily. Vertical scaling with SQL works well for applications with predictable, moderate data growth.
If you like this video, Hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.